Each week, science is taught in about 25,000 primary schools behind closed doors. Today, one teacher has kindly agreed to let our cameras in to share one of her first lessons of the autumn term.
Today, Year 6, electricity, first time with the equipment, that'll be quite interesting. I'm looking for them to develop their communication skills today with discussions in groups and in pairs. I want to gauge really where they're up to, get a good knowledge myself of where we can go from here. You'll notice there's something missing off the board. What's not there that we normally have? What's missing? Madeline?
Learning objective.
Learning objective's not there. Let's see if somebody at any point, the first 10 minutes of the lesson, can tell me what that learning objective is going to be. Okay, in the middle of your table are some brown envelopes. There is a picture card, and it looks like an actual picture of a component, an electrical component. There is a symbol card, and there is a definition. So there's 3 cards that will need matching up. A symbol, a picture, and a definition. One of the things I'm looking for today is you using the names of components.
That will go down.
What is it?
No, there's only 3.
Should we leave?
One cell would be that then, wouldn't it?
Leave that and then sort of
Then it'd be that one. Those. Which one looks like a buzzer out of those 2? We're not sure about these 2 because these are 2 batteries and that's a battery.
So 1 on its own is a cell, 2 or more than 2 is called a battery.
Battery and the bulb. 1 battery.
One person in your pair, show me what you've got as your picture, symbol and definition for a motor. Switch. Whole class, well done. With the other people on your desk, I would like you to discuss your bulb choice.
That looks like it's the bulb attached to the bottom. That's the bottom of that and that's the bottom of the bulb. We're thinking that's a hazard.
Hazard.
Yeah, because the bulb's kind of like a warning. Gets hot, doesn't it?
Okay. Why might I need, instead of drawing perhaps a motor, I use, as you showed me, this symbol. Why might I do that? Emily, what do you think?
Because it's quicker.
It's quicker. Any other reasons? Maddie?
If you were writing something down about electrical bits, and would it
bits?
just be, well, like bulb or something like,
Okay.
circuits or something like that?
Okay.
And could it just be like a freehand type thing? Instead of writing motor, you could just do a symbol.
It could be. So you can definitely match a component, that was the word you were looking for before, a component, to a picture or to an actual object. Okay.
If you drew the motor, people might draw the motor differently, and because the M with the circle around it might be international, an international
Brilliant.
sign.
The one that we've come to that we're not sure about is our bulb. Some people have chosen this. Some people have chosen this. And I have to say that those of you who had managed to work that one were correct. So, unlucky if you chose that one. I was very pleased with the way you were thinking about it and the way you were trying to sort of justify your choice. Now, if you need to, on your table, make sure that you change your bulb symbol over. What do you now know this symbol to be?
It's the buzzer.
The buzzer. Good. Okay, lesson objective. It's missing. What do we think our lesson objective is going to be? Coral.
Is it electric circuits?
Something to do with electric circuits. That's a good start. What else can we add to that? John.
To identify components of an electrical circuit.
To identify components. Brilliant. Key word. Fantastic. What do you think, Beth?
And to put them together safely.
Safely. I like that idea. Electricity, definitely a safety issue in there. Brilliant. By the end of the lesson, you will be able to recognise a circuit symbol, and you will also be able to use that to construct a circuit accurately and safely. You are the power source. You are our switch. Okay, so Gina, can you show me what you might look like if you were a bulb that had no electricity running through you and no power source and you weren't working? You're a working bulb now, show me. Fantastic. Right, just a cell, just a switch. Almost as a partnership if you wish for your circuit to work. Please show me a working circuit, Ben. Excellent. So what have the rest of you got to think about now? Because your switch is now working. The switch is closed. Well done, Gina. Good stuff. We'll pass round to Gina's happy. Somebody switches it off. Fantastic. So the bulbs start working. Gap in the circuit. I would like to see whiteboards, one each. Out. Please draw the correct symbol for a motor. Show me boards. Next one I want you to draw me is the symbol for a buzzer. Show me your buzzers. Can I now have a bulb drawn on your boards, please? As correctly as you think the symbol should be drawn. Carol's table, can you please show me your boards? Sophie's table. Open switch. If this was a switch you could see, would the if it was for a light, would the light be on or off? Beth, what do you think?
Would it be off because the switch is pointing upwards, so the electricity can't get straight through to the bulb?
What is there in the circuit that's preventing the electrical current travelling through there? What do you think, John? A gap. A gap.
Press that quite firmly, don't you?
So there won't be a gap for the circuit.
Brilliant. Yeah, if you don't press it hard enough, what will happen?
It won't turn on.
That's right, it won't turn on. Good girl. How do you think we're going to connect everything at once?
We're going to make it around the edge.
Yeah.
We're going to get these and put them around the
Okay, right, so we'll have a go then.
No, I did it wrong. I know, I got it. Let there be light. Let's put the switch in. Come on. We need an extra one.
With one previous lesson on electricity, Zoe's class have used circuit boards before. However, the key objective here is to see if they have learnt to translate the components on the boards into the symbols in their books.
Yeah, I see it. Okay, I have to do that.
Switch again. I remember.
That's meant to be there, Sam, that bit.
You just turn that one round. Are you sure that's meant to go there?
It goes along the wires, and the switch can make a break in it.
That's a short.
Okay, now.
Get in.
Now we're going to
Secure that. One of these. I've got all these.
It was losing electricity, so the bulb was dimmer.
So we're going to try the light and the buzzer this time. Okay then. Okay then, let's see if you can do that then. I'm sure you can.
We put it there and it'll save us using the wire. Oh yeah, that's true actually, isn't it? Okay.
Okay, try the
Okay, that should work now. Oh, the light this.
Now, what have you just done?
We've added another crocodile clip and added to that.
Okay, so Zoe has connected. So we've now got a bulb that's working. What do you notice about the brightness of the bulb?
It's not as bright because it's only using one.
It's only using one cell. Fantastic.
Yeah.
Just grab hold of that buzzer for me. Everything working?
Yeah.
Yes? So why do you think that's happened? Because we must have had an electrical circuit, we must have had a current. You've now got almost two, haven't you? You've almost created two separate circuits, but running from the same. Fantastic. Let's disconnect before I get a headache. Draw that and write me down what you did.
We had an extra battery to try and light the bulb and it didn't work as well.
Have you added the battery or a cell?
A cell.
Thank you.
Jay, look at our switch. Oh,
Those are the questions up on the board. Have a good look. You're going to have a chat with your partner in a minute and I'm going to give you about a minute and a half. You are going to tell me what your partner said. Okay. Go.
I'll do it first. Yeah, you asked me. One thing you've learned tonight. How to make a circuit. One thing you found difficult tonight. Well, I found putting a circuit together quite difficult.
If there's not much in the cell, there's not much light. I've learned how to draw and do the symbols correctly. I found it difficult when we tried to collect them all together.
I've learned all the signals, the signs for it, the symbols.
And I found difficult how to make the buzzer work and the light at the same time. But then we found out, so I know now.
What would I like to know next? If we would have been able to add an extra battery with the buzzer, the switch and the light bulb worked.
Lucy.
What he'd like to know is how to put the buzzer in.
We got it in, but they were working at different times. So if you put the switch on for the light would work, but the buzzer wouldn't, because the electric was going up the one wire, round the switch and buzzer circuit, and then to put a circuit in by itself, and then back down to the same battery.
Well, that's definitely something that perhaps we can investigate in the future, isn't it? It's definitely something we can find an answer to. Emily!
Short circuits give you more power.
What do you mean by shorter? I'm going to ask Rob. What did you mean by shorter, Rob?
I meant by you went for the battery and straight to light, then back to the battery.
And what do you think Rob would want? What did Rob say he wants to find out next?
How batteries get their power.
How batteries have their power inside them. Fantastic. If we manage to get a working circuit today, we can connect a circuit accurately. The interesting thing will be to see how well we've managed to record it and how well we can recognise our symbols.
In Zoe's lesson on circuits and components, she firstly ascertained the children's level of understanding using card matching.
Please draw the correct symbol for a motor.
The whiteboards provided Zoe with a quick way of checking the children's progress.
You are the power source.
She used roleplay to visualise a circuit with cell, switch and bulb.
Fantastic. We've passed round to Gina's happy.
The class experimented and then recorded their work as circuit diagrams.
Let there be light.